In a Rankine cycle, steam with an enthalpy of 3227 kJ per kg is expanded in the turbine to a state where the corresponding saturated enthalpy of water is equal to 537 kJ per kg and saturated enthalpy of vapor is equal to 2717 kJ per kg. Here it is a common data question. It consists two questions. Here the first question is, if the pump work requirement is 5 kJ per kg, amount of heat transferred in the boiler is, assuming pumping of saturated liquid. And here the second question is, if the dryness fraction of the steam at the exit of the turbine is 0.85, what will be the work done by the turbine? Here first draw the Rankine cycle for the given problem. Let us say on the TS coordinates. Here it is pumping the saturated liquid, so that, and this is the heat transfer in the boiler, and this is the exit of the turbine at a dryness fraction of 0.85. Let us say they are the points 1, 2, 3, 4. So here 4 to 1 is the heat transfer in the boiler, and 1 to 2 is the expansion in the turbine, that is work done by the turbine gives this expansion process. And here 2 to 3 is the heat rejection in the condenser, and here 3 to 4 is the pump work. So here we will have to find out the amount of heat transferred in the boiler is. So here the amount of heat transferred in the boiler is equal to H1 minus H4. And the second question is, if the dryness fraction of the steam at the exit of the turbine is 0.85, what will be the work done by the turbine? Work done by the turbine gives H1 minus H2. So here already H1 is the known value, that is the enthalpy at the entrance of the turbine is given by 3227 kJ per kg. So here H1 is enthalpy of steam at the entrance of the turbine and is equal to 3227 kJ per kg. Now we'll have to find out the H2 and H4. Here H2 is equal to H3 plus X into HFG, where X is the dryness fraction of the steam, and here H3 is the enthalpy of saturated water at this point, that is at the point 3, and HFG comes from H3 plus X into, let us say this point is some 2 dash, so H2 dash minus H3. So this is the equation for to find out the H3, and this is the formula for H2. So here H3 is a known value, and this is at the exit of the turbine, the saturated liquid enthalpy and saturated vapor enthalpy. So here enthalpy of saturated liquid is given by 537, and enthalpy of saturated vapor is given by 2717. So that H2 is equal to 537 plus, and it is 0.85 into 2717 minus 537, which gives a value of 2391.7 kJ per kg. So that here we have found the value of H2, and also we will have to find that H4 value. H4 is nothing but H3 plus pump work, and here pump work is given by 5 kJ per kg, and H3 is equal to 537, so that it is 537 plus 5 is equal to 542 kJ per kg. Now substitute these two values in the heat transferred in the boiler and work done by the turbine, so that here heat transferred by the boiler is equal to H1 minus H4, which gives a value of 2685 kJ per kg. So in the option, the right option is A. And for the second question, work done by the turbine is H1 minus H2. Here H1 is 3227 and H2 is 2391.7, which gives a value of 835.3 kJ per kg. So the second option is, the right answer is B. The heat capacity at constant pressure of a thermodynamic system is expressed as Cp is equal to 2.1 plus 42.1 by T plus 100 joule per degree centigrade, where T is the temperature of the system in degree centigrade. The system is heated while it is maintained at a pressure of 1 bar. until its volume increases from 0.002 meter cube to 0.0025 meter cube, and its temperature increases from 0 degree centigrade to 100 degree centigrade. The magnitude of heat interaction is here. It is a linked answer question in such a way that the second question answer depends on the first question answer. Here the first question is the magnitude of heat interaction, and the second question is increase in internal energy of the system is. So here we know that dq is given by the heat interaction is given by mcp dt. So now cp is a function of temperature here. Write it down and take the heat interaction is equal to 0 to 100, and m is consider per kg, and here cp is a function of temperature, that is 2.1 plus 42.1 by t plus 100 into dt. Now integrate this equation, we get here this is 2.1 t from 0 to 100, 100 to 0 plus 42.1 into ln of t plus 100 again from 0 to 100. So here now substitute these values in the given equations, we get here 239.17 joules. So the heat interaction of the system is 239.17, and it is generally here he asked about just the magnitude of heat interaction, but it doesn't mean that whether it is for heat rejection or heat addition, but it is generally here the temperature increases from 0 to 100 degrees centigrade. So obviously it is an heat addition process, and we will have to find out the increase in internal energy, that is du. The change in internal energy is given by dq minus dw, but we know that dw is equal to pdv. So here p is 1 bar, that means 10 power of 5 newton per meter square, and dv is the change in volume is 0.002 minus 0.0025. Sorry, it is 0.0025 minus 0.002. So from this equation we can have it is 50 joules. So now the change in internal energy is equal to 239.17 minus 50, which gives a value of 189.17. So it is equal to 189.2 in the option. The right option is A. Consider the following face center cubic lattice structure shown in figure. So here is the given diagram, and the it is a linked answer question. It consists two questions in such a way that second question answer depends on the first question answer. Here the first question is the atomic radius for the face center cubic lattice structure is, and here the second answer is the atomic packing factor for the face center cubic lattice structure is. Here the atomic radius is nothing but the given r, we have to find out so r is equal to how much. So here from the figure we can write it down, the you can take this as a right angle triangle, so that is with sides a and hypotenuse 4r. So from this, from the diagram we can have that is 4r whole square is equal to a square plus a square. So that from this again r is equal to a square by 16 by root of 2a square by 16, which is equal to root 2a by 4. So in the options the right answer is C. C for the first question. And coming to the second question, atomic packing factor is nothing but the volume of atoms, it is the ratio of volume of atoms to the volume of unit cell. Here volume of unit cell is equal to a cube, but here we will have to find out the volume of atoms, and for FCC structure the number of atoms is equal to 4, so that the volume of 4 atoms is 4 into 4/3 pi r cube, and here already we have found that r is equal to root 2a, that is 4 into 4/3 pi into root 2a by 4 whole cube. So from this it is equal to pi a cube root 2 by 6, and here the atomic packing factor is equal to pi a cube root 2 by 6 into a cube, so which is equal to nearly 0.74, and in the option the right option is D. D is the right answer.